Alright, we're going to simplify some radicals. We need to be able to break these numbers down into numbers that are perfect squares. So if you look at 72, what can you break 72 down into, one of which being a perfect square? Well, 72 is a factor-rich number. You can divide it by 2, and maybe this is helpful. You can divide it by 2, and you get 2 times 36. That gives you the exact same value of 72. I haven't changed anything here. Now, take a look at what's under the radical here. There's a perfect square. There's something that we can square root, and we can get out from being under the radical. So if I square root that, it's going to come out here. It's going to go in front of the radical. And I will now have 6 on the outside, because the square root of 36 is 6. I'm going to look at the other things under the radical, and I'm going to see if there are any perfect squares in there. Well, number 2 can't be broken down in any meaningful way. I mean, you could say 1 times 2, but that's not really useful. 2 is a non-perfect square. It stays on the inside. Let's do another. 500. Again, what can we break 500 into? One of the factors being a perfect square. Well, 5 times 100. The 100 is a perfect square. When you square root it, it comes to the outside, no longer under the radical, and you're left with 10 root 5. Again, root 5 is still under the radical because you cannot square root it. All of these have the same value. Root 500 is the same value as root 5 times 100. It's the same value as 10 root 5. All I'm doing is simplifying and reducing things. I'm not changing the value. Look at 300. Again, what can you break it down into factor-wise, where one of the factors is a perfect square? 3 times 100. 100 is a perfect square. Square root it, you get 10. 10 comes out of the radicand, and you're left with 10 root 3. 90. 90 is one of these numbers that's kind of factor-rich. There's a lot of things you could do. You could do 3 times 30, 9 times 10. But you need to find, and now I suggest to you that you find the highest perfect square possible within a number. So we're going to do 9 and 10. 9 times 10 gives us 90. 9 is a perfect square, so it's going to come out. So we're going to have 3, and then maybe something left in the radical. Look at 10. 10 you could break down to a couple things. You could do 2 times 5, neither which is a perfect square. 1 times 10, that doesn't help you. So 10, non-perfect square. You're left with 3 root 10. It's the same value as root 90. Once you start getting to variables being involved, you have to realize that you can square root any variable that has an that has an even power. Any variable that has an even power. B squared breaks down to b times b. That's what it gives you. B times b is b squared. So if you were to square root b squared, you're just left with b. If you're to square root c squared, you're left with c. So the radical in this one goes completely away. Square root of b squared, c squared, is just simply bc. This question you have to do a couple of different things on in order to get it to work. You're going to have to deal with the number, 98, and you're going to have to deal with the letters. Now, 98, let's take it a step at a time. 98 can be broken down into 2 times 49. X, it's just a single x, so there's nothing to do there. And y squared has an even exponent, so we can square root that. So I'm going to circle the things that we can square root in here. We can square root 49, we can square root y squared. These are the 2 things that are going to come out and be on the outside. Everything else is going to stay under the radical. So let's see. 49 squared is 7. Y squared is y. And then we have 2 times x left in the radicand.